Hello everyone, welcome back to our video series, Foundations of Private AI. I'm Satya Shrestha, a Senior Staff Executive Services Architect at VMware. And with me today, I have Sun Huntley, a VMware Subject Matter Expert on Private AI. Welcome back, Sun.
Hey, thanks for having me, Satya.
Awesome, man. And in this second episode, in this video series, we will be covering AI application foundations, right?
That's right. So yeah, we're going to go through some of the more introductory concepts for some things that you might not know about AI, general introductory concepts about what sort of patterns are common with AI applications and how we need to sort of think about an infrastructure platform to build those sorts of capabilities.
Absolutely, man. Let's get straight into it.
All right, cool. I wanted to start with what is a model. Here, there's been a lot of excitement about large language models and a whole bunch of different stuff that we all call AI and machine learning and what's the difference and all of those different things. So I just wanted to start with the concept of like, what is a model and what are we doing here?
Yeah.
So the models that you might be familiar with are large language models where we might be chatting with something, right?
Yeah.
And that is a model that's taking text and
Mhm.
converting it into text. It's making a prediction about
Yep.
what the next part of the sentence or the next part of the conversation is. So this is
Right.
a predictive model and it's based on statistics and a bunch of really cool maths behind the scenes, but there's just effectively a really big statistical model behind the
Yeah.
scenes. And we've been using these types of models, not necessarily the text type, but models for recommendation systems. So you might think of like what movies you get recommended on Netflix or
Yes.
any of these sorts of things, right?
Streaming services.
Right.
Yeah.
And so
Yeah.
there's a whole bunch of different models here that we can consider AI or machine learning.
Mhm.
And these models are from video to text or text to video. You might see of things, models that convert text to speech. That's one that's
Right.
been done, or speech to text. All of these sorts of models, that's all it is. It's just a statistical mapping that takes some form of data input and converts it into another type of data input. It can be the same type, so text to text and trying to predict the next part of the conversation, but effectively
Right.
it's just trying to predict the next thing.
Yeah. So you said about the large language model, right? We hear a lot about, for example, OpenAI's ChatGPT, then we have Grok, and then so on and so forth. So let's just talk about Grok and OpenAI for a bit. So Grok and ChatGPT, so they would be using their own model to do their analysis and do the kind of like a chat interface or that sort of thing.
What these sort of large language model providers are starting to do is
Yes.
connect a whole bunch of different models and what we call sort of multimodal models now. So they're
Right.
connecting a whole bunch of different models and training models that are more and more comprehensive and
Mhm.
connecting them to their large language models. So, you might be using ChatGPT and it can process a photo now, right?
Yes.
And it's not just predicting the next part of the conversation. So
Mhm.
there's a whole sort of environment of different tools and documents and videos and data formats effectively that these models are starting to want to consume. Now,
Yes.
these big providers that you talked about, they are definitely training their own models. That's one of the characteristics of these large enterprises. So what they're really doing is consuming a huge amount of data. In some tech cases, really the whole internet, like all of the text data that they can get. And
Yeah.
again, they're trying to predict the next part of the conversation with these large language models. And what that takes is a huge amount of investment from both a capital perspective, purchase GPUs, and a time perspective and expertise perspective, right?
Yes.
And
Yes.
it's super high cost. These models, that's what we're calling a training from scratch. Now,
Mhm.
you might have also heard of this other term called fine tuning. And fine
Yes.
tuning is where we might grab a model that's already been made and we're
Right.
just going to get an extra bit of data and tweak it. So,
Yes.
for example, the original large language models were just predicting the rest of a sentence. And
Mhm.
what happened over time when ChatGPT got released was they really started fine tuning these models for chat, which meant that it was fine tuned on responding to questions and answering those sorts of questions, right? And
Right.
the same could be said that you could fine tune it on different sorts of data. So you could fine tune these models on conversations that are more oriented around science or maths, or another one that's more focused on legal. So these are
Right.
sort of more focused, dedicated models.
And domain specific models.
Yeah, exactly, exactly.
Right. Right. So talking about this training, right? LLM. These are usually the big providers or these big companies, hyperscalers. Are they the ones who are mainly working on creating this kind of large language models?
Yes, there's kind of two distinct categories that I would put this into, which is that we see a lot of proprietary models and
Yes.
a bunch of open models. And
Mhm.
so, and these can be from the same vendor. So, for example, at the bottom here, we have Gemini and Gemma. They're both provided by Google. So that's a large hyperscaler that's doing that. In the same regard, OpenAI has ChatGPT, but they've been talking for the last few months about releasing another open source model in the coming months.
Oh,
So
nice. Right?
yeah, it's a really exciting time in the industry, right?
Yeah.
And
Yeah.
so There are these proprietary models that we generally see that you'll need API access to, or you might run in a cloud in a VPC, dedicated hosting. So those are sort of where we see proprietary models getting used.
Yeah.
Now, on the alternative side is the open model space, which
Yes.
is coming from organizations like, again, Google with Gemma. We see Meta creating this Llama ecosystem, DeepSeek, and Mistral. These are
Yeah.
all really large open models, and we can start to go and run them on our own infrastructure wherever we want. So some people are running them at home on their home setup. Some people are running them in their data center because they're really just close to the same level of performance as these proprietary models.
Yeah. So just talking about the philosophy here, right? Proprietary model versus open model. What is motivating, for example, for the open model people? Why are they doing this for as an open model versus proprietary model? What do you think?
It's pretty interesting play. I won't necessarily speculate on the economics of it all, but
All right.
I think that there's a huge amount of open source software, right? And so all of the same learnings that we have about open source software and the commercial models that back open source software, it's the same
Yes.
for models. And models are just effectively a new type of software and a new type of digital artifact that we need to learn and run and manage and do all these sorts of things with. Most of the incentives there are the same as doing open source software, and the commercial
Right.
models
Right.
are
So
probably,
so
yeah.
then there are so many models here in the screen, right? So are they all made for special purposes, or are they competing with each other? What do you think? Let's just pick few of these and then talk about it. What do you think?
It's all just really fascinating where the ecosystem in the industry is going. The amount of cost to train these things, and it's actually one of the fastest devaluing assets in history, right? The
Oh,
cost to use these models and even give them away for free is surprising how quickly model access has gotten cheaper and cheaper. And so it's really encouraged a very open ecosystem. So,
yes.
and what we're seeing in the industry is these different models are leapfrogging each other one at a time. And
Right.
most recently, Grok 4 and Super Heavy and all of this stuff has been all of the big news, right?
Exactly.
Saying, oh, is it better than OpenAI? Is it better than Llama?
Yes.
What they do is they just leapfrog each other. A few months ago, we were in the previous episode, where all of the news was about DeepSeek, right? And we had
Mhm.
that conversation. So
Yep.
the main takeaway here is we want to be robust. The changes in whatever is the state of the art best model, right?
Mhm.
And
Yeah.
so being able to select from different vendors and, in fact, have control over running our own models, as well
Mhm.
as being able to have the flexibility to choose between those models, is a really, really important part
Right. Right.
of
And like you said in your earlier slide, that these proprietary models are open models that they are training. It takes like thousands and thousands of GPUs and really heavy investment, right?
yeah, that's right.
Yeah. And then like smaller players wouldn't do that, isn't it? They're
Yeah.
creating at time. Yeah.
So you mentioned small players, and so I wanted
Yep.
to talk about what do we actually want? Everyone's talking about, oh, well, I need to fine tune or train my own model. If that's not the case, what do we actually want? Well, most of the customers I talk to just say, well, how do I improve a pre-trained large language model with
Yeah.
my own private data? How do I add domain specific context? And
Yes.
there's three ways that we've seen to do that, which
Mhm.
is first we can do this thing called prompt engineering, where we can
Mhm.
add a little bit of data in that initial prompt. We can do another pattern called retrieval augmented generation, which I'll explain in detail, which
Yep.
really is just like a database lookup, really, of data that's
Uh-huh.
relevant. And then we can start to use agents to do more tasks and connect different data sets together.
Right.
So, prompt engineering. This is a really kind of basic way to do this. So, when
Mhm.
we're using a large language model, when we initialize that conversation, there is a thing that we use called a system prompt. System prompt is going to tell the model how to behave in this conversation. That's kind of like its base programming almost. And
Right.
so here I can say the system prompt is speak like a private pirate, so it's going to
Mhm.
respond like a pirate. But I'm also going to inject a little bit of context. So today's date is the 7th of the 7th, right?
Mhm.
And so now when any user comes along, if they ask what's the date, well, it's going to give the date in a pirate context, right? So tuning the system prompt really affects the model behavior, but there's
Yeah.
not really much room to add heaps and heaps of data. And that data is really static, right? You can see that by adding the date like this, I'd have to have inject that data every single time, and it would be a quite painful process to do that.
Yes. Yes. And this is it mainly around generative AI, like what we're talking about here, or is it could be?
Yes.
Yeah.
Yeah. We know that large language models aren't perfect because they start to hallucinate. They start telling us information that isn't real or doesn't exist or is not
Yes.
factual. They're not up to date. When those model providers train those models, and if we're using an open source one and we're running it in our own infrastructure, it's only as current and as the last time it was trained. So that's
Yes.
seeing this sort of pattern of, maybe fine tuning isn't the best path forward because it implies that we need a huge process to keep fine tuning that model, to keep it up to date, latest data.
You're right.
And then we can't really trace where the data it's coming from.
Mhm.
trained it or fine-tuned it in that way. And so
Yes.
there's this new pattern called retrieval augmented generation, where
Mhm.
we're going to connect the large language model through our application with a new type of infrastructure object, which we call a vector database. And
Right.
the idea behind this is how do we sync this LLM with validated information that we can update whenever we want, and that
Yep.
the LLM can cite which information it used to come up with its answer.
Vector DB is the DB that holds the proprietary data. Is that how it is, or
That's right.
that we could have that as well?
This is just one way of doing search and adding data, but this is by far the most popular. And so to understand really what's going on here, we have to understand what a vector is and why do we even need to put it in this database.
Yes.
What we're really doing here when we think about vectors is how do we search a large corpus of data
Mhm.
for semantic meaning, right? I.e., a word like we're looking for every reference to pirates within my
Yep.
database, right?
Yep.
And so what we do is we get bits of data and say this one's talking about bread and food and produce. And what we
Mhm.
do is we use another model called an embeddings model. And this embeddings model converts words and concepts into numbers. And the
Yep.
closer this set of numbers is, I've only put one here, but the closer this set of number is to each other, it indicates kind of how close in an ideas space these two
Right.
things are,
Right.
right? So you can see here rockets. These two rockets are quite similar to each other, but
Right.
a rocket compared to an apple is not very similar, so their numbers are
Yep.
very different.
Yep.
And so what we do is we populate our vector database with
Mhm.
all of these different types of data that we might have. And so you
Yes.
see, again, all of the round things are kind of close to each other. There's
Yep.
stopwatches and then a steering wheel and a speedometer is they're quite close to cars, and cars are sort of similar to trucks. And you can sort of see how we can sort of build a map of things that are similar to each other. And then you can imagine the different numbers that represent these things.
So in terms of the numbers, right? Who actually does this numbering? Let's say 0.911 for that food kind of category versus rockets, etc. 0.033. Who does that kind of numbering? And like you said, the matching of similar kind of number pattern.
Yeah, so what we use is another type of model to do that, and that is
Okay.
called, we were talking about the types of models at the beginning.
Yes.
This type of model is a text in to a number out model. So what
Right.
we can do is, and it's called an embeddings model. And so
Mhm.
what we do is we're going to create these vector embeddings by giving that model a bunch of text. So it's, it might say apples and oranges are my favorite fruit. And
Yes.
we convert that sentence into a number by giving it to the model, and then the model will spit out a number, right?
Right. Right. Right.
And
Got it.
so that
Mhm.
model is doing all of the labeling for us in terms of converting them into vectors.
Yes. Okay.
The vectors are then very handy because we can start to set search with these vectors.
Right.
So, for example, if I come along and I say, hey, I would like to know more about utes in
Mhm.
Australian speak, but for a global audience, maybe a truck
Truck.
would be the better pickup or truck or whatever.
Yep.
But so here I'm going to go and use that same model and embed it into that same format. So here I can say I've got a number of 0.145. Now, what I can do is say, hey, what are all of the things that are
Mm.
close to this number? So if
Yes.
I'm asking the model about pickup trucks, what are the sort of things in my database that are related to pickup trucks? Oh, I've got some things in my database of people talking about cars or commercial trucks. And I can return them as a list of results, right?
Yeah. Right. Mhm.
So once I've done that, I can see all of the things in my database that are relevant to any individual query. And this is what we call vector search.
All right. And then all these values are stored in vector DB. Is that right?
That's right. So we store both the text and the vector in a vector DB so
Right.
that we can query it later and get some really fast querying.
Okay. Okay.
So now you might be wondering, well, now I can search for things semantically. I can sort of
Yeah.
see where these numbers are coming from. I can see things. What does that actually look like?
Mhm.
Well, now what I can do is I can start to build out a whole ecosystem of running a large language model with what's called a RAG pattern, where I get
Yes.
a whole bunch of data and I embed it using another embeddings model, and I
Mhm.
store that inside my vector database.
Yep.
Then I can set up an application and say, hey, here's my prompt from the user. So the
Mm.
user is saying, what's new in VCF 5.2?
Yes.
I'm going to encode that query using that embedding model. And then we're going to do that same search process that we did before. And
Mm.
in doing so, we're going to get a list of similar things
Uh-huh.
to that query. So I've said, what's new in VCF 5.2? Well, when I've retrieved that domain specific data, I might get back the release notes for VCF 5.2 because that's most similar document to the
Mhm.
question that was asked, right?
Yep.
And
Mhm.
now my application has a whole bunch of data that's relevant. So what can I do? Well, now I can go and give that data to the large language model. in a sort of enriched prompt. So I can say to the LLM, what's new in VCF 5.2? Here
Yep.
is some relevant data to answer your question, right?
Mhm.
And now the LLM can synthesize all of that data and
Yep.
give us a really clear response that synthesizes all of that data. And the
Right.
great news is that we can go and update the data in our vector database whenever we want. And as long
Mhm.
as we keep that updated, the LLM is always going to be updated with fresh data, and we don't need to retrain it every single time there's some context that changes.
Right. Right. So this enriched prompt that also gets stored somewhere.
The enriched prompt we don't store. It's just kind of like local context that we're just going to ask the LLM, right?
So it's like a byproduct or middle product before it goes to LLM to get an
Exactly.
answer. Okay, got it.
Yeah. We're just the only things we need to store is our private data in this sort of vector or encoded form.
Right.
Or everything else, it's up to the application if they want to store it. But generally, we don't store any of these things apart from the conversation history.
Yeah, got it.
Yeah. So now we can start to think about another interesting pattern here, which
Mm.
is how can we enable a large language model to do more things rather than
Yes.
just reading data? How can we enable it to interact with different tools? And so in this example, what we're going to see is how a large language model can call an API on our
Hmm.
behalf.
Right.
So, for example, there might be a weather API. And
Yep.
so I might say, hey, what's the weather in Sydney? By the way, I've got a weather API available, right?
Yes.
And then the model's going to come back and say, oh, well, I'd actually like you to call that. I'm not going to give you a response. I want you to call that API, tell me the response, and then I'll tell you the weather, right?
Yeah.
But
Right.
the
Right.
interesting thing here is that it's converted. It knows how to call that API from the basic data that we've given it. So, for example, you can see it's converted Sydney into the specific coordinates that needs to be called on that API, right?
Right.
That's quite useful to us.
So in this example you just said, right? So when LLM is querying the API and is getting that specific, very specific information, for example, for Sydney, so that is kind of like an enriched prompt for LLM. Is that the
Yeah,
right analogy?
exactly, exactly. So it's been enriched with this tool call because we're giving
Right.
it a bit of metadata
Yes.
at the time, right? And
Yep.
so it's kind of like a little bit of JSON at the end, right? That says, hey,
Yeah.
I've got
Right.
these tools. Here's how you can call them. Here's how you can use them.
Yep.
And
Yep.
then our application can do that on behalf of the large language model.
Right. Got it. Okay.
Yeah. And so in this case, you can see steps 2 and 3, we have done that on behalf of
Mhm.
the large language model.
Yes.
And now we're going to merge those two things. So we say, hey, LLM, here's the response. We're going to forward that information to you. And then the LLM can use that enriched data plus the original call that came through in
Yep.
step 0. And it's going to merge those two things and say, okay, the weather in Sydney is, hot and sunny. Right?
Yes. Yes.
The cool thing is, it's not just about reading data.
Mm.
We can do other sorts of things like writing data, for example.
Right.
We can start to, write to a DB. All different APIs aren't just read only, right? Once
Yes.
we have an amount of trust, we can start to think about giving the LLM access to write or update APIs.
Yes.
There's also a whole bunch of exciting sort of protocols that are coming out for these sorts of things. One of them is called Model Context Protocol, and it's getting quite a bit of excitement at the moment. And what this is
Right.
doing is it's starting to act as a facilitator of all of these calls to
Yep.
external services as a
Mm.
wrapper around an API that makes it very friendly for a model to use.
Yeah. Right. Okay. So the idea here is basically all the vendors to start using model context protocol for this kind of purposes, right?
Yeah, exactly. To be able to sort of streamline the development of these things, it's a lot easier.
Yes. Absolutely. A good standard.
Yeah. So now if we have a large language model that can call tools,
Hmm.
that's now we're at this point where we can kind of consider it agentic. And there's a lot of excitement. I'm sure you've heard about agents in the news, right? It's got a lot
Yeah.
of excitement.
That's the new buzzword now, agentic AI, right?
Yeah, yeah, totally. And so here I can say, oh, can you add Judy to my meeting with Tom on Friday?
All right.
And now the LLM has a whole bunch of tools that are connected. So it's got a calendar, it's got emails, and it might
Yes.
have like a RAG system that might be connected there as well. And so what it can do is it can start to operate in a bit of a loop and say, well, to figure out who Tom is, I should probably check the emails. Oh, and I can
Mm.
see, oh yeah, that's Tom Jones. And okay, now I'm going to go look at the calendar. Okay, there's the meeting with Tom Jones on Friday at 3 p.m. Okay, add Judy to that. Who's Judy? Oh, I've sorted emails with this sort of Judy person. And it's going to
Mm.
keep making these tool calls in a loop until it completes the task. And then it will output that result to the user and say, okay, now I've gone and I've called all these different APIs and I've added Judy to the meeting on Friday, right?
Yes. And
And
LLM is doing this autonomously without any extra input, right?
right. And so you can sort of imagine a slider of being able to choose how much autonomy you want to give these
Right.
large language models, right? You don't want to give it complete access. And
That's right.
in many of these emerging agentic systems, there's a lot of approval gates being added to add a lot of governance and control around these things.
Super.
Yeah, in theory, what we're seeing is these sorts of patterns where it's operating in a loop and it can start to do things autonomously and make decisions like this.
Yeah, this is nice.
Okay, so now we've done a little bit of an introduction on what it takes to sort of the different sort of application patterns. I wanted to
Yes.
talk about what it takes to sort of build these things and what we need to think about in that category, right?
Yeah. Yeah.
So the first thing is we need to start thinking about selecting what model we want to use. So there's a
Mm,
whole bunch of different open source models. We need to determine which one is going to work for our use case. Are we familiar with it? How does it perform? And will it run on the size cards that we have, the GPU cards, of course?
yeah.
Then we need to start thinking about, okay, how do I actually run this thing? How do I run it, run inference requests? And how do I actually get access to the resources I need to do that? So
Yeah.
I'm provisioning an LLM. Do I have a GPU workstation? Where can I do tests? A whole bunch of like self-service developer infrastructure, right?
Mm,
The next step is how do I start preparing data? So
mm,
in that RAG example, not just data, but tools and all of these different pieces. So how do I prepare that domain specific data? How do I make sure it's in my vector database and start building those different parts of it?
mm.
And then finally, once I've done all of those things, I can start to combine all of these different tools and systems together into an application.
Yes, right. So in this example here, this model selection and environment setup is this kind of task is performed by ML engineers, persona, and then AI developers do the other bits, data preparation and app dev. Is that how it is?
It's sort of an emerging ecosystem, like depending on this on how large an organization it is. We're seeing, ML engineers that might do some of the more compliance stuff and set up large language models for inference and do some of these more complex domain specific tasks.
Yes.
But at the far end of the spectrum, developers really just want to be able to call APIs
Yeah, that's it.
to build their applications that are doing the business focused stuff here, right?
I want
And
to do environment setups and all this nitty-gritty, right? That's
yeah,
what and just develop the application.
yeah, and so I mean, you can kind of think about it in the same regards as like we have DevOps
Yeah,
staff, right?
yeah,
And then we have developers, and the DevOps staff are really just trying to help make developers more productive with
yes.
build systems and tooling and CI/CD and all of these different things, right? You can think of this ML engineer or ML ops category as sort of in that same vein. It's like, how do we
Yeah,
make these application developers really productive, right?
yeah, makes sense, makes sense. Yep.
So the tricky thing is that if we're doing it just once,
Mm, mm,
it's quite easy to do, right?
yeah.
If you're just one person, you're like, okay, I can figure out one model I want to use. I'm
Mm,
going to go and I can set this up for inference. I can sort of bumble my way through that. And there's, some great tooling out there for that. And then I'm going to figure out the data piece and then I'm going to figure out the app dev piece, right?
yeah, yeah.
Why we start to need more team members and start to do this is because we're wanting to repeat that process. We're
Yeah.
wanting to have multiple projects going on at one time. We have multiple different teams to support through this process.
Mhm.
And there's a lot of challenges that start to come up once you're wanting to do this at scale.
Yeah. So it's more like developing a system that can repeat the thing and also optimize as you go, right? That's sort of not like a one-time exercise.
Exactly. It's not just a one-time exercise. So
Yeah.
one of the first questions we might ask as an organization is, what models are we allowed to run as an organization? If
Mhm.
team one and team two are running the same model, but they're off by like, one version number,
Yeah. Yeah.
that worth it to me as an enterprise for the security risk and like being able to compliance management and all of those different pieces, right?
Yes.
What models are we going to approve and how do we think about those sorts of things and how do we govern access to those sorts of things, right?
Mm.
The other thing is what GPUs and infrastructure are available to these developers, right?
Yes.
And so
Yes.
we see a whole bunch of teams who go for this sort of shadow IT or shadow AI, where they're running off to any service to just try and get access to the infrastructure that they need to
Yeah.
get it, right?
Yeah.
Because if they don't have to worry about setting up the inference server, then why bother, right? I can just swipe my credit card and do that,
And
right?
then they just go to the big hyperscalers and then just spin it up as and when needed, right? And then the other department may not know that is happening. The same thing is happening with the other department, right? That sort of thing.
Exactly. And then you have a whole bunch of teams using fragmented infrastructure and your costs start to blow out, right? Because you
Exactly.
don't have control over of all of these systems and all of these teams and what tooling that they're using, right?
Yes.
So we believe that the solution here is taking a platform approach.
Yeah.
So we've got to start thinking about these model consumption and governance, right?
Mm.
So how do we establish patterns for consumption? Where
Yes.
do we store models locally so we don't have to, go out to a cloud server to go and grab a model when we need it just in time? How
Yep.
do we reduce our supply chain attacks with secure infrastructure that's going to run these models? And
Yep.
then how do we control access and provide accountability for when these models are taken and how they're used and the costing associated with running these models?
Yeah. Bit of a guardrail there as well. Yep. Yep.
Yeah. So adding a bit of maturity and governance to this sort of new ecosystem.
Yep.
And so this platform approach, you'll see the first step is really how do we start to store models locally so that we can run them when we need to? So our security team can facilitate a list of validated models that have been scanned and approved by the organization
Yep.
that our developers can go and choose from to run
Mhm.
their applications. So this is
Yep.
the sort of first step that we could see.
Mhm. Mhm.
Now, what are the other steps that we're going to still have to do? Well, we're still going to have to get access to infrastructure. I'm still going to have to set up inference myself. I'm still going to have to prepare data. But what we
Yep.
can start to do is add more platform capabilities to do this sort of thing, right?
Right.
So here's where we're sort of taking a cloud-like approach to thinking about this. So
Yep.
next, we want to be able to have self-service infrastructure.
Mhm.
So virtual machines, Kubernetes, GPUs, databases as a service. How do I get
Yes.
access to these things as and when I need them? So, for
Yep.
example, that RAG application piece that we saw before, I
Yep.
need access to a vector database. And
Mm.
if my local IT team can't deliver that to me quickly, then maybe I will run off and go and do it somewhere else because I can't get the agility I need from my platform.
Yeah. Exactly. Yep.
Next up, what we can start to think about is, well, if I'm helping with self-service infrastructure, well, the
Mm.
next part I have to do is run an LLM. What makes sense to me is having a model runtime service where we can start to get shared model inference. And this is going to make a huge difference to both the security and governance of our organization, but also a huge difference to the costing and the return
Mm.
on investment for actually purchasing GPUs.
Yes.
And the reason for that is because a lot of time our AI applications look like this. We've got an individual AI application with
Mhm.
a virtual machine, a database, a Kubernetes cluster. They're all their own individual island. And what
Yep.
we're seeing is that an individual model is being bound to the GPU. And this causes really, really poor GPU utilization.
Right. Right. So it's the same LLM component being used by all these different, for example, applications, which could actually have been optimized, right, and better used if it was done in a platform approach kind of thing, isn't it?
That's right. And so what we're doing is we're wasting all of this infrastructure
Yes.
because, and this is some great research from UC Berkeley, this is how our inference loads stereotypically are varying over time. Here's a few
Right.
models that are running here. And we can see that we have to provision GPUs for peak load.
Mm.
And so they're actually underutilized for the off-peak period. And that's for any individual model, right? That's one piece of it. The second is you can see here, I'll just point out to the right-hand side,
Mhm.
roughly 5 to 30 minutes. Looking at like one of the more common times, that's the wait time before you're starting to use a model. The distribution between when we actually have a model just sitting there idle and then the
Yes.
first request coming in is about
Yes.
30 minutes in these cases.
Right.
Sometimes it's 1 to 5. You can see it varies from model to model.
Mm. Yeah, I was
So
going to say mostly it is being idle, right? Not really doing nothing, just waiting for another thing to be processed. That's how it looks like here.
yeah, exactly. So your GPU has this model in memory. And if you
Yes.
go and look at the performance of this GPU, you'll be able to see the memory utilization is very high. It's doing its job, right?
Mm.
But the compute utilization of your GPU, it's not actually serving any inference. And
Oh,
so your utilization will be extremely low.
yes.
So what's the right approach here? The right
Mm.
approach is to actually consolidate at a platform layer and start to say, okay, how can we start to provide models to multiple applications?
Mhm.
Here you can see app 1, 2, and 3 and the developer environments
Yep.
might be able to choose from model 1, 2, or 3, and our infrastructure can handle serving that. And we
Mhm.
can load balance these applications making use of these different models, right? We can
Yep.
scale them out. So model 1 is clearly popular. So I've got, 4 GPU cards helping run model 1. And then
Mhm.
model 2 and 3, maybe I don't need as large a GPU footprint to run those models. And here we can start to run them like that.
Mhm. Mhm.
The good news here is that we can saturate the GPU utilization by making sure that we can get a higher base load.
Yes. So this is basically really optimally utilizing the resources, right? And then the idle time we saw earlier, lowering down that idle time.
Exactly. And yeah, their baseline load is we just creep it up.
Yeah. Yeah.
So once we've got a model runtime service, the interesting thing that we need to start thinking about is how do I start breaking down all of these different data silos, right?
Wrong.
what sort of tools exist for me to query all of that enterprise data that I might have stored in, SharePoint or a Google Drive somewhere or Confluence, and how do I start to prepare that data for
Yes.
retrieval augmented generation? And importantly, be able to connect that to my model runtime service, right?
Right.
So all of that data, remember at the beginning we were talking about how we had to prepare all of that data and put it into our vector database.
Yes.
That's no small task at an enterprise scale, right?
Yeah.
Especially if we have routine data sets, we have access control, we have governance considerations of who can access what sort of knowledge. All of these sorts of things are really important to tightly control and have a sort of governance approach to.
So this platform capabilities to developers, who is providing this to AI developers?
It's really where the core IT team can start to provide these services
Right. Right.
as part of the IT business. And
Mm.
now, maybe in the same way that you have maybe DevOps engineers in your team, or you might have some experts on your team that can run models. But
Yeah.
the
Right.
point being is in a private cloud operating model, it shouldn't matter who is supporting necessarily the services. If
Yeah.
it's an individual team who has enough capability to go and say, yes, I want to run this model, go for it, right?
Yeah.
If you are a larger enterprise and you have dedicated teams that are, have a doing all the security scanning, approving models, and then running those models on behalf of the rest of the business. That's also
Yes.
another way of doing it. So it really depends on the size of the organization, I'd say.
Mhm. So it's pretty much optimizing the resources, bringing in those guardrails and compliance and governance, right? Giving them the visibility and operations, monitoring, that sort of thing. And again, like you said, the self-service critical piece here that AI developers can go and pick and choose what they want, what resources they want, and then just develop the applications, right?
Exactly. And so we can start to build all of these capabilities up, all the way from the foundational infrastructure components, like running a model store where we store the
Yes.
models, moving through to getting access to the compute that we need with GPUs and Kubernetes and VMs and databases and all of those pieces. Then start to build AI developer tooling so that we don't have to repeat the same old tasks every single time. And this is a really infrastructure-led approach to running AI applications. And you can see the amount of work for the application is much smaller once we have this sort of capability.
Exactly. Exactly. A lot of heavy lifting done there for platform capabilities. Yeah.
That's right. And so what I would like to introduce today is also the VMware Private AI Foundation with NVIDIA. What we've done here is a great combination of products and tooling from both the VMware Cloud Foundation all the way up to the NVIDIA AI Enterprise. And so this is a best of breed solution with access to all of the different capabilities for a platform approach to
Yes.
a private AI foundation. So we have all of the great infrastructure capabilities that VCF offers,
Yes.
including workload security, multi-tenancy, all of the GPU controls, etc. And then we can
Yes.
start to up-level it with richer capabilities for running those AI platform capabilities like building agents and running models, and then combining that with some of the highly performant capabilities from NVIDIA AI Enterprise as well.
Yeah, that sounds really cool, Son. Yeah, this is good. And interestingly, this is going to be our next episode, isn't it? We'll be double click on each of these in our next episode in a greater depth, isn't it?
Yeah. So next episode, we're going to go into depth about each of these different capabilities. In the following episodes, we're going to go through live demos of some of the cool new capabilities here.
Excellent, man. So then that's it for today, isn't it?
That's it.
Awesome, man. Yeah, it was really a pleasure discussing about the AI application foundations today and what capabilities we need and what capabilities we can offer to the AI developers. Next episode is specifically going to be about VMware Private AI Foundation with NVIDIA.
That's it. See you next time.
Awesome, Son. Thank you again. And thanks everyone for watching. And we look forward to seeing you again in our next episode. See you all.
Thank you.
Bye.